Good evening everyone, welcome to another lecture of engineering mechanics. This is lecture number 19, Kinematics of General Motion. In today's lecture we are going to cover a very important topic known as instantaneous center of rotation. What is instantaneous center? Why do we use it? We are going to talk about all of this. We are going to solve numericals based on this concept. And let me tell you, if you understand this concept very well here, it is going to help you a lot when you will study theory of machines. But before starting today's lecture, let's first solve the question that I gave you in the last class as an assignment. A cord is wrapped around a wheel of radius 1 meter, which is initially at rest. If a force is applied to the cord, which gives it an acceleration of 40 meter per second square, where t is in seconds, number of revolutions made by the wheel after 5 seconds is. So understand what is happening here. Here basically we have a cord which is wrapped around a wheel of radius 1 meter. Okay, let's say this wheel is hinged at the center. Okay, and we are applying a force of how much? Some amount of force we are applying, due to which it gives it an acceleration of 40 meter per second square. So the acceleration of this is 40 meter per second square. Okay, number of revolutions made by the wheel after 5 seconds they are asking. Okay, now understand this. Whatever acceleration this cord has, tangential acceleration of this point will be same. Let's say this point is point P. So the tangential acceleration of point P will be equal to 40 meter per second square. Why? Because we have to assume that the cord does not slip on this wheel. Although it is not mentioned, but without assuming it, we will not be able to solve. Okay, so if a cord is wrapped around a wheel and there is no slip, then whatever is the acceleration of the cord, the tangential acceleration at the point of contact will be same. So the point P is on this wheel and it will also have the same tangential acceleration, not a total acceleration. Okay, this is going to be the tangential acceleration. Okay, the direction of normal acceleration will be this, tangential acceleration will be this. So tangential acceleration is equal to 40 meter per second square. Okay, now what is tangential acceleration? Tangential acceleration will be alpha into r, and for point P, r will be equal to this radius. So what is r? Radius is 1 meter, na? So alpha is equal to 40. So now we have the value of alpha. But what do we need to calculate? We need number of revolutions. And for number of revolutions, we need theta. So from alpha, how do we find theta? First, we will have to calculate omega. Then from there, we will calculate theta. Right? So alpha is equal to d omega by dt, which is equal to how much? 4t. So I can write d omega equals to 4t dt. Now understand this. We need the equation of omega in terms of t. So this will be this. Initially, when t was 0, omega was 0, right? Now understand this. I am not putting 5 seconds here because I don't want the value of omega at a particular time. I want the equation of omega in terms of t. That's why I am putting t here and omega here. So this will become omega equals to 40 square by 2, or I can write 2t square. So this is the equation of omega in terms of t. Now from here we will calculate theta. So omega is equal to d theta by dt, which is 2t square, right? So d theta will be equal to 2t square dt. Now you calculate theta at t equal to 5 seconds. So initially it is 0. At 5 seconds, what will be theta? So it will become 2t cube by 3, 0 to 5. So theta will be equal to 2 into 5 cube by 3. I am getting 83.33 radians. But we need to find number of revolutions, right? So number of revolutions will be theta by 2 pi. So 83.33 divided by 2 pi. And you will get 13.26. The answer is 13.26. I hope you got this. So now let's move on to today's lecture, which is on kinematics of general motion. Okay. Now what do we mean by general motion? Understand, I told you that whenever a body is moving in a plane, we can divide the motion into 3 categories. It can be either pure translational motion, or it can be pure rotational motion, and if it is neither this nor this, then we will put it in a category of general motion. General means it is neither pure translation nor pure rotation. For example, if your hand is moving like this, it is general motion because this is neither pure translation nor pure rotation. We can assume this motion to be translation plus rotation. Every general motion is a combination of translation and rotation. Okay, let's understand this by an example. Okay, let's say that a wheel is moving on a flat surface. Okay, let's say this is your wheel. Okay, it is moving on a flat surface by rolling without slipping. What do we mean by rolling without slipping? Look at this, look at this. This is rolling without slipping. Can you see? It is rolling on my hand. This pen is rolling on my hand and it is not slipping. Okay, so when the wheel of an automobile, a bike or a car moves on a flat road, it is rolling without slipping. So let's say it moved from here to here. Okay, understand this. This is the center O. It came here, O dash. Let's say this is a point A and it came here, A dash. Now understand this. How it moved from here to here? It was rolling without slipping. Okay, if you see, this A first translated from here to here, right? First it translated from here to here. I can assume that it first translated from here to here, and then at this point it rotated from here to here. So this motion is combination of translation from here to here, then rotation. Okay, first it translated, then it rotated. Okay, so every general motion is a combination of translation and rotation. Now in order to solve problems of general motion, let's say I want to calculate velocity of a particular point, we have a very interesting method, and this method is known as instantaneous center method. Okay, now first let's understand what do we mean by instantaneous center. Instantaneous means what? At a particular instant. Okay, for example, let's say a car is moving, okay, on a road. It started at 12 o'clock and it moved till 2 p.m. from 12 to 2 p.m. okay. Instantaneous velocity of this car means at a particular instant. For example, let's say at 12:30 p.m. what was the velocity of the car? So that velocity will be the instantaneous velocity of the car at 12:30 p.m. At 1 p.m. what was the velocity of the car? So that velocity will be the instantaneous velocity of the car at 1 p.m. because from 12 p.m. to 2 p.m. the velocity was not constant. At every instant, at every second, the velocity was changing. So that is why we calculate all these things at a particular instant, which is known as instantaneous, right? Now, let's say a body is in general motion, means combination of translation and rotation. At any particular instant, if I want to calculate velocity of a particle on the body, let's say this body is moving like this, but I want to calculate velocity of this pen at a particular instant. For example, let's say at this instant, when it was moving like this, at particular instant, let's say t equal to 5 seconds, it was here. At this instant, I want to find what is the velocity of the tip of the pen. So I want to calculate instantaneous velocity of a particular particle. At this instant, I can assume that this pen is under pure rotational motion about some imaginary point. It's not actually under pure rotation. It is under general motion, means translation plus rotation. But if I want to calculate the velocity of any point on this pen at any instant, I can assume that at that instant, for say example, let's say t equals to 5 seconds, it was under pure rotation about some imaginary point. This imaginary point is known as instantaneous center. Now you will say, sir, why are we assuming it? Because we know how to calculate velocity under pure rotation. V equal to omega into r, where omega is the angular velocity, r is the distance from center of rotation. So if you assume that this body is under pure rotation about some imaginary center, then if you know the location of that center, you can easily find velocity of any particle. You just need to calculate V equals to omega into r, where r will be distance of particle from instantaneous center, imaginary center of rotation. Now, this imaginary center is not a fixed point. In case of pure rotational motion, your center of rotation is fixed. For example, let's say I hinge this pen here, and then if I rotate it, its center of rotation is fixed. It will always be this at t equals to 0, t equals to 1, t equals to 2, t equals to 3. At every instant, the center of rotation will be same. But in case of general motion, I am assuming that it is under pure rotation at particular instant about some imaginary center, right? This imaginary center will not be fixed. It will keep on changing. For example, at t equals to 1 second, let's say your imaginary center is here. At t equals to 2 seconds, your imaginary center is here. At t equals to 3, the center is here. At t equals to 4, the center is here. So this imaginary center of rotation will not be a fixed point. At different instants, this imaginary center will be different. So if you want to find out the velocity of any point, you will need to find out where this imaginary center is at this particular instant. For example, if I want to calculate velocity at t equals to 5 seconds, I will find out the imaginary center, means I center, at t equals to 5 seconds. If I want to find the velocity at t equals to, let's say, 7 seconds, I will find out I center at t equals to 7 seconds. So you will need to understand how to find imaginary centers. Now let me tell you, this topic is also in theory of machines. When you will study theory of machines, you will study this I center method again. But in theory of machines, we deal with mechanisms which are combination of different links. Links means different bodies, let's say. So different bodies are combined together and they form a mechanism. So in that case, there are more than one body, 2, 3, 4, 5 bodies which are connected together. So there the eye center method becomes a little more complicated. Here we are only considering a single body. Here we are considering problems related to single bodies. Okay, so this is the basics of eye center. When you will study theory of machine, you will study the advanced concepts of eye center method. Okay, so if you understand the basics here very well, it will help you to study theory of machine. Okay, now there are 3 cases where we will learn how to find eye center. Okay, 3 different cases. In each case, finding eye center will be a little different. Okay, so let's consider the first case. Case 1 is when you know the direction of velocity of any 2 particles of the body. What do you know? You know the direction of velocity. You don't know the magnitude, just direction of velocity of any 2 random particles. But their velocities must not be parallel to each other. Okay, so let's imagine that this is a rigid body. Okay, and there are 2 particles. Let's say this is particle number 1, let's say this is particle A, and let's say this is particle B. Okay, and we know the direction of velocities of these 2 particles. Okay, let's say the velocity of B is horizontal. Okay, and let's say the velocity of A is like this. Okay, I don't know the direction, magnitude of velocity. I just know the direction of velocity. And you can see that VA and VB are not parallel to each other. So how do we find the eye center in this case? Understand, we will have to draw 2 normal lines, perpendicular lines from A to B. Perpendicular to what? Perpendicular to VA and VB. Okay, so first I will draw a perpendicular line to VB. This is a perpendicular line to VB passing through point B. Okay, then I will draw perpendicular line to VA passing through point A. You can see that this is perpendicular to this and this is perpendicular to this. Now the point at which both these perpendicular lines are intersecting is your eye center. So I hope you understand how to find eye center in case 1. We have the direction of VA and VB. So what we did, we have drawn one perpendicular line from B perpendicular to VB, another perpendicular line from A perpendicular to VA. The point at which both of these are intersecting is your eye center. Now once you know the location of this eye center, you can easily find out the magnitude of VA and VB. How do you find out the magnitude of VA and VB? VA will be equal to omega into IA. VB will be equal to omega into IB. If let's say there is some other particle VC, some other particle C, you can find the velocity of that particle also. VC will be equal to omega into IC. So you just need to find the location of this eye center. Okay, sir, how we will get the value of omega? In order to find the value of omega, you will have something. For example, in some questions, they will directly give you the value of omega. Okay, But in some questions, what they will do is they will give you the magnitude of one of these velocities. For example, let's say you have VA. Okay, in the question itself, they have given you VA. And now you have found the I center also. So you know the value of IA. From the geometry, you can find the value of IA. So you have VA, you have IA. You can find the value of omega. Okay. So in order to find velocity of any particle, you need location of I center and you need omega. Location of I center, how to find that we are already seeing. Omega will either be given in the question directly, or they will give you the velocity of any particle to find the value of omega. Okay. Now, this was case 1. But it is only valid if VA and VB are not parallel. For example, let's say VA is also horizontal, VB is also horizontal. Then the normal to VA and VB will never intersect. They will also be parallel. Perpendicular line to VB will be this, perpendicular line to VA will be this, if VA is also horizontal. Then both of these lines will never intersect. So you will not be able to find the I center. So what will we do if VA and VB are both parallel to each other? Then how we will find the I center? So that is your case number 2. What is case number 2? Let's say you have the direction as well as the magnitude of VA and VB. What do you have? You have the direction as well as magnitude of VA and VB. Let's say this is A and let's say this is B. Now, let's say VA is 10 meter per second and it is horizontal. I'm just assuming, okay? So this is the velocity of A, 10 meter per second. Let's say VB is 5 meter per second. Now, if I am drawing 10 centimeter line for VA, I will draw 5 centimeter line for VB because VA is 10 meter per second, VB is 5 meter per second. So 10 centimeter line, 5 centimeter line. So we know the direction as well as the magnitude of VA and VB. Okay. Now what we will do, understand. We will draw two lines. The first line will be the line joining A and B. Okay. This is the line joining A and B. And the second line will be the line joining the heads of A and B, VA and VB. This is the line joining the heads of VA and VB. And the point at which they are intersecting is your I center. So you are drawing two lines here. One is connecting A and B. Another one is connecting the heads of VA and VB. Now, what if VA and VB are opposite to each other? Understand. Let's say this is A, this is B. Let's say VA is like this and VB is like this. Let's say both are opposite. Then also you do the same thing, na? One line connecting A and B, another line connecting the heads of VA and VB. So in this case, the I center will lie between A and B. So once you get the I center, you can easily find the velocity of any point. So this is case number 2. Now, third case, very important case. The third case is for a particular type of general motion, which is rolling without slipping. It is the motion of the wheels of automobiles, bicycle, cars, trucks, bikes, all these vehicles. When they move, the wheels of these vehicles are basically rolling without slipping. Now, in case of rolling without slipping on a fixed surface, let's say this surface is fixed and a wheel is rolling without slipping on this surface, the eye center is actually the point of contact, the point at which this wheel is in contact with the fixed surface will be the eye center. Why? Understand. See, when the wheel is rolling without slipping on a fixed surface, then at the point of contact, relative velocity must be zero. Relative velocity means what? The difference of velocity of the wheel and this fixed surface. So relative velocity must be zero, means whatever velocity the fixed surface has, the wheel will also have the same velocity at the point of contact. Now the velocity of this surface is zero, right? Because it is fixed. So velocity at the point of contact should also be zero. So if the velocity of this point is zero, it must be the center of rotation, na? Velocity is only zero for center of rotation, right? For all the other points, you will have some velocity, right? Only at point of center of rotation, your velocity must be zero. So if the velocity of this point is zero, it means it is the center of rotation, right? Yes? Chalo. So this is the third case, rolling without slipping. So here it is very easy to find the eye center, na? Point of contact is eye center, that's it. Okay. So we have these three cases of finding eye center. Case number one, when the direction of velocities of two particles VA and VB are known, magnitude is not required, only the direction is required. Okay. Then what do? We draw normal lines from A and B perpendicular to VA and VB, and the point at which they intersect is your eye center. Second case is when the direction and magnitude both are known and VA and VB are parallel to each other. So here what we will do? We will draw one line joining A and B, other line joining the heads of VA and VB, and the point at which they are intersecting is your eye center. Okay. Third case is the case of rolling without slipping. Now here the point of contact is the eye center. Let's solve a few questions, okay, on these concepts. So the first question is this: a rod of length 1 meter is sliding in a corner as shown. At an instant when the rod makes an angle of 45 degrees with horizontal plane, velocity of the midpoint is 14 meter per second. Velocity of the end B at this instant is. Understand what is happening here? When the rod of length 1 meter is sliding and it is at an angle 45 degree, velocity of the midpoint is 14 meter per second. And now we need to find the velocity of B. Okay. So how we will solve this problem? Understand. Velocity of the midpoint we know. Now first we will calculate the eye center. First we will find the eye center. Okay. Now this rod is sliding on these two surfaces, right? This rod is sliding on these two surfaces. This is point A, this is point B. So the direction of velocity of A and B are known. A must be along this line because it is sliding on this surface, na? And B must be along this line. This is a very important question because it is very frequently asked. A lot of times we have this question. Okay, so VA and VB, the direction of VA and VB are known. Now, in order to find the eye center, what we are going to do? We will draw one line passing from A perpendicular to VA, and we will draw one line passing from B perpendicular to VB. And the point at which both these lines are intersecting is your eye center. So now we have got the eye center. Okay. Now what they are asking you to find velocity of point B. Okay, sorry, this is so sorry. This is VA and this is VB. This is point A, this is point B. Okay, so they are asking you to find the velocity of point B. Now, in order to find the velocity of point B, we first need the location of eye center. That we have found out. But we also need the value of omega. And in order to find the value of omega, they have given you the velocity of the midpoint. I told you, they will either give you the value of omega directly, or they will give you the velocity of some point. Okay, so they have given us the velocity of midpoint. Now, midpoint means somewhere here. This is C. Okay, now we know that velocity of C will be equal to omega into R. What is R? Distance of C from center of rotation, means IC, right? Now I will tell you a very interesting concept. Understand, huh? If the length of this rod is 1 meter, then the distance of this point from the center will be half of 1 meter. Okay, this is a very important concept of geometry. Why I am asking you to remember this is because you will find these type of questions quite a lot of time. Okay, they are very frequently asked, so it is better to remember this. Okay, you can prove this. How you can prove this? Understand. Okay, see, if I want to find this line, I will make a triangle like this. Okay, whatever this angle is, it doesn't matter, it will always be same. Now understand, let's say this is how much, what will be this is the center, na? So if this is L, this will be L by 2 cos theta, right? If this is L and this angle is theta, this is L cos theta. So from center to here, L by 2 cos theta. Now this is L sin theta. So from center to this will be L by 2 sin theta. So this is L by 2 cos theta, this is L by 2 sin theta. Now this is the resultant of L by 2 cos theta and L by 2 sin theta. Calculate it. Sin square theta plus cos square theta will become 1 and you will get this L by 2. So whatever is the angle theta, whether it is 45 degree or 30 degree or 60 degree, this will always be equal to L by 2. Okay. So we have this I to C 0.5 meter. Now velocity of C is 14 meter per second. And from I to C distance is 0.5. So omega is 28 radian per second. We have got the value of omega. So now we can find VB. VB will be equal to omega into IB. Okay. And omega is 28. From I to B, this distance will be 1 cos 45, right? 1 meter is the length of the rod. So this will be 1 cos 45, na? From I to B. So it is 28 cos 45 means 14 root 2. 19.5 79 something means 19.8 meter per second. If you find out the velocity of A na, that will also be the same because this angle is 45 degree. So this distance and this distance, both these distances IA and IB are equal. So VA and VB will also be equal. Okay. Chalo. So I hope you like this question. Now let's move on to the next question. A circular disc of radius 10 meter is confined to roll without slipping at A and B as shown in figure. Okay, look at this. This is a circular disc. Let's say these are two plates. Okay, plate A is moving at 12 meter per second, plate B is moving at 8 meter per second, and between these two plates we have this wheel which is rolling without slipping between two plates. If the plates have velocities as shown, the distance of eye center from point B is. Now understand, you might be thinking, array, this is the question of rolling without slipping, so eye center will be the point of contact. No, it is not case number 3. Case number 3 is rolling without slipping on a fixed surface. Here this wheel is rolling without slipping on moving surfaces. So here beta, you will not apply case number 3. Understand? Let's say this is your wheel. Okay. This is point number A and this is point number B. Now understand. The plate is moving at 12 meter per second and there is rolling without slipping between this plate and the wheel. So at this point, the velocity of the wheel will also be same, 12 meter per second, because relative velocity must be 0, na? Velocity must be 0. No, relative velocity must be 0. Relative velocity means whatever will be the velocity of the plate will be the velocity of the wheel. If the plate is fixed, then the velocity will be 0. But if the plate is moving at 12 meter per second, the velocity of point A on the wheel will be 12 meter per second. Similarly, the velocity of B on wheel will be 8 meter per second. So I have drawn a line equal to 12 meter per second here. This is 12 and this is 8. Now how I will find the eye center? First I will draw a line connecting A and B. So this is my line connecting A and B. And then I will draw a line connecting 12 and 8. And the point at which both of these are intersecting will be the eye center. So I have got the eye center, okay? Now they are asking us to find the distance of eye center from point B, okay? So let's say that this distance is y. So what will be this distance? This total distance will be equal to the diameter, na? Radius is 10. So the diameter will be 20. If this is y, this will be 20 minus y. Some people write it 10 minus y. They are wrong. See, this is the diameter, na? This complete length is diameter 20. So if this is y, this will be 20 minus y. Now just apply similar triangle between this triangle and this triangle. Apply the similar triangle. So y by 8 will be equal to 20 minus y by 12. So it will become 12y equal to 160 minus 8y. So 20y equal to 160. So y will be equal to 8 mm. Sorry, 8 meter. Not 8 mm, 8 meter. So the distance of the eye center from point B is 8 meter. Okay. So this is actually case number 2, not case number 3. Let's move on to the next question. A 3 meter wooden plank is tumbling as it falls in the vertical plane. Okay, when the plank is in horizontal position, velocity of ends A and B are shown in figure. So at a particular instant, this rod is not moving like this. Okay, it is tumbling something like this. At some point, at some instant, this rod becomes horizontal. Velocity of A is 5 meter per second, velocity of B is 2 meter per second. Now we need to find the velocity of midpoint G. So in order to find the velocity of midpoint, we need to find the eye center, right? So how do we find the eye center? So this is the rod. This is point A, this is point B, and this is point, let's say, G. The velocity of A is 5 meter per second and the velocity of B is 2 meter per second. So this is case number 2 because both the velocities are vertical. This is 5, this is 2. So how we will find the eye center? One line joining this, another line joining this. So somewhere here will be your eye center. Okay, let's imagine that this is the intersection. Okay, now I need to find the velocity of G. This will be the velocity of G. Okay, this will be the velocity of G. So how do I find it? Similar triangle. Okay, this distance is 1.5 meter. This distance is 1.5 meter. Let's say this distance is x. So if I get the value of x, I can find the value of Vg. So how do I get the value of x? Apply similar triangle between this bigger triangle and this triangle. Okay, you can't use this triangle right now because you don't know Vg, but you know this 5, you know this 2. So one triangle will be this one, the big one, and one triangle will be this one, the small one. Okay, so it will be the bigger one. For the bigger one, I can write the entire distance will be x plus 3, right? X plus 3. This entire distance will be x plus 3 divided by 5 will be equal to x divided by 2. I have applied similar triangle between this bigger triangle and this smallest triangle. Okay, so this distance is x plus 3 divided by 5 equal to x divided by 2. So it will become 2x plus 6 equal to 5x. So 6 equals to 3x. So x equals to 2 meter. Yes. So now we have got the value of x. Now we can find Vg. So apply now similar triangle between this and this. So it will become x plus 1.5 by Vg, or Vg upon x plus 1.5 equal to 2 upon x. So it will become Vg upon x means 2 meter, na? So Vg will be equal to what? 2 plus 1.5, 3.5 meter per second. Okay, so this is the velocity of the center G. you can also do this. Okay, no, we have to find the eye center. Okay, now moving on to the next question. A rod AB of length 1 meter is sliding in a corner as shown. At an instant when the rod makes an angle of 20 degree with the horizontal plane, velocity of point B on the rod is 10 meter per second to the right. Find the velocity of the end A. We will have to find the velocity of the end A. Now this is your assignment question. We have already solved a type of this type of question. So you can easily solve this question on your own, right? We know the direction of velocity of A. This will be the direction of velocity of A because it is sliding on this surface. This will be the direction of velocity of B. So you know the direction of VA and VB. You can find eye center, and from there you can find the velocity of A. Okay. So this is all about eye center, but I told you that these are the basics of eye center. You will study the advanced concepts of eye center in theory of machines. So in engineering mechanics, you have to deal with only these type of simple problems from eye center method. Okay. So this is the end of the kinematics part. Now from the next lecture onwards, we will start with kinetics. So I will see you in the next lecture. Till then, bye bye. Take care. Good night.